Hi everybody, and welcome back to my lab. Today I just wanted to give you a quick little update. We've got 1 week left of class, and then I'm into doing my final marking and getting your grades out to you the following week. And so next week, what's due is basically everything. Your project was going to be due this week, but I extended it till next week. But you do have your test next week. And now it's a practical test, and I don't want you to freak out. I know there's a lot on your plate right now. Everybody's under an extraordinary amount of stress right now. But if you've been following along and doing your project and doing your lab assignments, this is just a test to show me that you can actually do the work. Like our other tests, it's open book, open resource. I don't care how you get it done as long as you are the one that gets it done. Um, Management gave us a bit of an update. All of the practices that were used for academic integrity are still in place, and I really don't want to have to go through that paperwork and deal with the drama of reporting you. So please be honest and do your own work. So what's all going to be involved in the final test? The final test is going to be basically a mini project. You're going to have a design criteria. You're going to go pick out some actual parts, make it work, simulate it, create a PCB, and a bill of materials, including costing. Okay, so it's everything in there, and I think there's less than a dozen components, so it's not going to be a huge issue for trying to source all those parts, but I am looking for accuracy. And so as with our other tests, I gave you a huge hint, and I'm going to do the same today. Now, previously we used a data sheet which had a design example. Today I want to actually show you something that is very powerful in Proteus that allows you as a learner to take advantage of this software package, okay? And so what I want to talk to you about are the design examples. And so here you can see I have an oscillator, and this is a simple, it's called an LC circuit. So this is an inductor capacitor circuit with a couple of resistors and a battery. And when we push the button, you can see that the capacitor and inductor will, if I actually simulate it, the capacitor will charge up, and the inductor, being DC, doesn't see any real change, so it's acting as a conductor. And when I release it, the LC circuit, the inductor starts to charge and discharge, and you can see it oscillate back and forth. And so this is an oscillator. Very simple one, and has a lot of practical applications, especially in radio frequencies. It's definitely a fundamental you want to learn. So how do you get to these designs? Fairly simple. You just go under File, open a sample project, and you can type in some keywords. In this case, we happen to be looking for an oscillator, and maybe I'll pick oscillator number number 2 here. And so this is called a stable multivibrator, and this one's kind of neat. It has a couple lamps, and should start to oscillate all on its own. The issue with these is if you happen to have perfect components, they won't self-oscillate. You have to bootstrap them. You have to give it a little kick to start it, but usually static interference in the atmosphere will be enough to get that started. And so here you can see the lamps flashing back and forth, and that's fine. Let's see what else we can get here. Let's open one more sample project, another oscillator, and this one will be a 555 timer. One of those things that is somewhat ubiquitous. They're taught everywhere and used nowhere anymore, in my opinion, because microprocessors have become so inexpensive. Okay, so I'm not gonna play around with that too much right now, but just trust me that it is working. There we go. It's actually working over here. And you can see as you play with the two resistor values here, you can change the pulse width modulation. So if you're looking for a low-cost pulse modulation circuit, you can hunt around the internet and find lots of stuff. Just one last view of the sample projects. There are a lot of them, and if you're curious about something, an LCD, for example, or some Arduino circuits. What else do I find in here? Just randomly looking. Blinking LED for Arduino, again, potentiometers, current, stepper motors. There's lots and lots and lots of information that's available for you to use as a starter. And that's your hint for the tests. I want you to look at the circuits in oscillators. Okay, it's going to be one of those. I want you to understand how the oscillator works. I'll go one step further. It's going to be the A-stable multivibrator. I want you to understand how it works, and then I'm going to give you some design parameters, okay, to design your circuit around. So again, this is CAD class. I'm not looking for testing your knowledge of electronics and understanding the circuit, but I want you to be very familiar with how it works. Okay? Thanks, and if you have any questions, any comments, any concerns, please send me an email sooner rather than later. Okay? That's it, and enjoy your last week of class.